Okay, we're up to stream number 15. Hello, Raimu here. I'm going to be working on the interboard communication between the two halves of my prototype keyboard here. And hopefully the code I wrote yesterday isn't a complete failure. Actually, I really hope that it just works. But realistically, probably going to run into some bugs. Probably going to break my own programmer and have to fall back to the those little buttons that are there. Let me put into bootloader mode, and we'll see how it goes. So I changed a lot of this code yesterday to use a new IBC submodule. So where was it in this decode? Yeah, so this codec here, which is an IBC codec. I wrote that yesterday. Let's see how we're doing. Yep. I wrote that yesterday, and I moved all of the messaging between boards into this enumerated type. So these are all the things that are affected. Greeting is used by this board to say hello to this board, so that this board knows it's a secondary board. As in, it's not connected directly to the PC. It's this one is directly connected from this USB port there. Key is used whenever I hit a key on the secondary board to let the primary board know about it. Log is used when we're, I guess I should start that program up. Whoops. File, new window. Open. Oh wait a minute, I don't need to open it a second one. We have this built into here now, right? I just need to have the right command. Should probably have a batch file for it. Not program, but just running this without the program step, right? Yeah, there's a little bit of delay sometimes. Anyway, what we'll see in a minute is messages of this type are for this board sends this board diagnostic log messages for this one to send back over the USB on the COM port class of the USB interface so that we can see like when we log something. And then program size and program sector are when this board is sending a new firmware image to this board, which happens when we send it from the PC. The program arrives here, it gets saved here in Flash, and it's forwarded over to this Flash. And when both of them have them staged, then they reprogram themselves at the same time. Anyway, so here's the log, right? If I hit a key here, you can see log messages. Also, if I hit keys on the left, similar log messages. So any kind of debugging, when I do log messages, I want them to show up here. Let's keep that window around. And this one, I'm just going to do build. I haven't dropped any frames yet. No, we've gone 3 minutes and 43 seconds. Okay, do I just try and see if this works? If it works, then I will need to change the monitor program so that it also uses IBC. It doesn't use IBC yet. So when it sends the program, it does it raw. So this has to change a little bit. I checked before the stream to see if log messages are also using IBC, and I didn't do it, and I probably won't. Because I kind of want the USB serial port class driver to just be sending text. And wherever we get text, I just want to print it. So where does that actually happen? Right here. Whenever we read something from the serial port, we just write it directly to standard out, which is what we're seeing down here. I think I want to keep that around. So, okay, I guess here goes nothing. So run my program script. And when it reboots, we'll see if it's completely hosed or if it actually works. Oh, It's working. That's great. That's great. Okay, will the reports work? No. The moment I hit a key, this crashed. What about the left-hand side? Left-hand side's working. Okay, so when this tried to send a key report, it crashed. Or this one crashed. I can reset it and it'll start up again, right? Wrong button. The right button is the reset button. Okay, cool. Can't send anything on the right-hand side. Log messages aren't getting through either. Well, that's bad, right? We should have seen something here when the secondary board booted up. It should have, like, said something. Something should have appeared here. Yeah, hitting a key crashes it. That's not good. Okay, so I got some debugging to do. I can see if this one can receive a program at least. Right? So now that he understands the IBC, the Interboard Communication Protocol, I can go to the monitor here and make that use it as well. So it already has the import there. Hey there, Lazy Guru. How are you doing? Here's where we send the program from the host to the primary board, right? And I kind of want to copy what I have. Is it in program.rs? Programmer.rs? Is this where it is? Yes, it's this. So we want that line here. And this line, well, it's looped, right? Hold on. I guess I originally just sent the entire program in one shot. We're not doing that anymore. Yeah, okay, so I have to have kind of a loop, the same as I do here, only this isn't really in a loop. Right, but it's over USB, so it's automatically flow controlled, so I don't have the to do the pause part. Okay, then, yeah, I want this over here in a loop of some kind. So this would be like, I guess it would be a while loop. So let, we know program.len. Oh, hold on. I need to do this part first. This part needs to be done before we send it, because we know the program size here. Okay. And then this gets sent where? Oh, this thing gets fully constructed as a slice into a vector. Okay. Okay, so then, hold on. Whoa, these are different types. How does this work? Oh, it's into bytes makes it into a vector. Okay, so then I want, yeah, I want to make a mutable vector to the message here. Because we're going to yield it right there. I guess I can take all this and comment it out to be deleted soon. Okay, and then you can't push into a vector a slice, can you? But that's just one element. But I can do, what is it, extend, append? I can't remember the name of it. Let's look it up. Is it extend? I don't think it is extend. Okay, what I really want to do is alloc vec and look at its methods. Extend from slice. Clones and appends all elements in the slice to the vec. That's what we want. We want to extend from slice. Actually, this in code gives me a vector. Then if vector goes into vector, can't I just call, what is it? There's another one where you can give it a, is it append? Yeah, I can call append. Moves all elements from one to the other. Okay, so we just append. And then I don't need to do as slice. Okay, I guess I do have to mutably borrow the temporary. Okay, great. So then let mutable offset equal what? 0? And then what? While offset is less than program size? We're going to form a program sector out of part of the program, right? So it's again going to be message append. Obviously in code, we don't need the as slice. So I would want to make a new vector out of a part of the program. So it'd be program offset to offset plus sector size. And we need to compute that, right? And I think I did it over here. Yeah, this one. Basically the same thing here. Okay, and we use program size instead of forwarding program size. It's just offset instead of offset. Sector size, I'll have to copy, I think. Yeah. That maybe should go into IBC or something. I don't know for sure, so I'll keep it in the monitor for now. Put it here. Okay. Okay, min comes from standard, yeah, we can use the standard library here. Okay, what's the error? What's the problem here? Oh, right, it wants to mutably borrow that temporary vector. Okay, an array of bytes can't be indexed by a range. Oh, it has to be a U size, right? So, well, anyway, I think it becomes a U size if I do something like this. Offset plus equal sector size. Why does it think this needs to be a U32? Program size is a U32, that's what it is. Okay, then... Yeah, I can put the as U32 here and remove it here. Then we have the correct types down here. Sector size needs to be a U size. Okay, cool. So now the types all work. So this is sending a program size followed by a program sector for every sector until the end. That should be good, right? And then I don't need this old stuff anymore. Put comments in here for now. So read program or firmware, read new firmware image into memory. Construct a program size message to initiate reprogramming or initiate firmware download, firmware upload. Add program sector messages to transfer each sector of the new firmware one by one. Okay. So the idea is this message is what we're sending to the device. If we're set to reprogram, it constructs all these messages in advance and it gets ready to send them out. Otherwise, we don't send anything. And then when we're in this main loop connected to the device, if we have something to send, right, the send buff, if it's not empty, then we just try to write as much as we can of it. And the send buff is a slice, right? So we're advancing the slice past the ones we already sent. So it basically tries to send the reprogramming commands as fast as it can, as quickly as the primary board will accept it. So, I mean, I guess I can give it a shot. Hold on. Let's remove this. I bet you this won't work, but let's give it a try. Oh, it's actually working. Okay, cool. I'm happy with that. So the primary board reprogrammed, the secondary board didn't. I noticed this was going a bit too fast. I wonder if it's because, oh, it's because before we would wait until we transmitted all of the sector to the secondary board before setting the timer, but now I'm setting the timer right away. I think I need to increase the amount for the timer. So if I reset this, is he hosed? Oh no. Right, because he was still running to the staging area, so it didn't hose anything. Okay, cool. I'm happy about that. That means the IBC at least works between the host and the primary board. And I can still use my programmer. That's still broken. We'll figure out what's wrong with the keyboard reports in a bit. Okay, cool. So it's not a complete failure. Let me check this in. So this was changes to update the monitor program to use the IBC for programming. Okay, git commit update monitor to use IBC for firmware updates. Git push. All right. Yay, not a complete failure. So let me try just increasing the timer. So if I remember, that's in programmer, right? Yeah, it should be a constant, but it's not. Where is it? Oh, I think it's because we give it the timer. So whatever is giving it the timer, right? This programming, sector programming timer. Here it is. And that's the other timer. Where do we use this? Hey there, Aura Driven. How are you doing? Hold on. Where do I set the interval? Maybe it is inside of next. I didn't see it though. Oh, there it is. Max sector programming time microseconds. So it's set to 100,000 microseconds. What if I just start conservatively by just making it 500,000 microseconds to start with? Let's see how that goes. Okay, and then Control C this guy, and then reprogram. See how this works. It's still sending it really fast. I think it's too fast, so... Oh wait, no, I have to program it once, and now it's using the new value. Right, I forgot about that. You have to do it twice. Okay, now it feels like it's the same rate as it used to be. Cool, look, it's reprogramming. This one didn't reset though. This one did, but this didn't. That's odd. Oh, he must have, the primary board must have hit the, no. I was gonna say it hit the watchdog, but, what state is it in? It's hosed? What if I reset it? Huh. Try that again. It turned from purple to red. I know it's hard to see the colors on my camera. Okay, something's different because now neither one of them actually resets properly. And then it makes it hard to tell if it actually is programming or not. Oh, I wonder if that timer is used in more than one place? Nah, it can't be it, can it? Wait, hold on. It's flashing quickly. That means it's got the greeting message, right? I can't remember now. I can't remember if the flash interval indicates that it received the greeting message or not. Well, there's a peer log message. Interesting. Huh. What happens if I hold down a key and then reset it? It gets hosed right away. That's what happens. Okay, something changed in how it resets at the end. So how do I tell what's going on there? I think the way would be to actually, let's change the color of the LED really quick to make sure it actually is reprogramming. So, where do I have the LED colors? That was in like reflect controller state here? Yeah, this one. So let's make it blue instead of green for a second. What happened here? How come? Hold on, what happened? I think I accidentally closed the file. Yeah, anyway, it should open that, and then I can do build. Well, really, I don't need two of these anymore, right? Yeah. And program. Oh, now this delay. Okay, what do I do while I'm waiting for that delay? I guess inspect the program and see maybe where it went wrong. It would be in the programmer here. We saw it turn red, which means it got to here. So for some reason, this doesn't work. I didn't change any of this, though. Oh, this changed, though. Ah, that multiplied by 5. Okay, so the watchdog is much longer now. I wonder if it's so long that it's overflowing. Because if it goes larger than 32 bits, it will not program the watchdog correctly, right? Actually, it still should work, right? So it's maybe 5 times longer than it used to be. This seems like it's never actually resetting. Okay, let me manually reset and see what happens. It's still green. It's not programming correctly. Okay. That's all I changed though, right? Changed that LED color and I changed the programming time. Let me change it back to see if we really are reprogramming. That I'm not super confident about. So that's back in Flash. Yeah, this thing. Let's set that back to 100,000. So it's not going to program the secondary board. It's going to be too fast there, but at least I can see if this is working. Okay, and then reset it myself. Yeah, I don't think it's working. So let me manually update it. Flash. Okay, now it turned to blue. Really hard to see in my own camera, but that is blue now. Okay. Let's try to program again. All right, then let's change it back to green. I'll just undo that, right? Build and program again. All right. So the watchdog thing doesn't work if that number is 500,000 for some reason. I'm trying to figure out why. So I'm guessing that it's overflowing. That it's, you know, I think I know what's going on. Where this calculation is overflowing, or it's going to a value that the watchdog can't accept, and then the watchdog is triggering right away. No, that can't be. That can't be. Gee, I don't know. Okay, then let's just leave that alone. Where we use this, let's just add another fudge factor, because we need to we need to account for the programming time, and we also have to account for the transmission time between boards, right? So let's just have 2 constants, one plus another. So we'll just say like sector transmission time. Plus. So I'll just need to define that. We can define it here in the programmer. Right now, where is it declared? It's in Flash. Okay, yeah, so we'll just put it up at the top here. And it doesn't need to be public. This is a conservative estimate of how many microseconds are needed to transmit a single 4 kilohertz sector of, will transmit the image to be written to a single 4. Why do I say kilohertz? That should be kilobyte. No one caught me on that. It's not kilohertz. It's kilobyte. All right, and then that's the constant's name. I wanted to add up to 500, so we'll make this 400,000. This is a conservative estimate of how many microseconds are needed to transmit to the peer board the image, an image, to be written to a single 4 kilobyte sector of flash. All right, let's build that. Just to make sure it gets actually reprogrammed. Let's toggle the LED color every time we do this. So that was back in keyboard, right? Yeah. So let's put it back to blue. Build in the program. It's the first time that will work, but that won't. Right, that's blue, and this is probably still going to be green. Correct. And I'll run it a second time to make sure this one gets programmed. 7, 8, 9, B, C, D, E, F, 10, 11. Okay, so that one worked, but that one stalled. That would stall why? It might still be using an old program. I might have to reprogram that one manually. I think I might have to reprogram that manually, so we'll do that. Just unplug that guy and plug him in, and now he becomes the primary board, right? Only I will hold down this button as I plug that in, and then run the flash command. Cool, and then we can flip the boards again. Is that connecting all the way in there? There we go. Okay, let's flip the color back, shall we? So, keyboard, right here. Just undo that change. Build. Program. Okay, he's forwarding now. E, F. They're both committing. Yes, it worked. Let's, just to verify, do it one more time. Reprogramming. Yes, all right, cool, it's working. Okay, so then next is to, well, I need to check this in. So I fixed that typo, and I introduced a sector transmission time, which I add to the timer. Okay, that makes sense. Okay, so Control C, let's check. This is just fixing a typo. I feel that that should get its own commit, so let's just check that in as fixed typo. Verify I'm checking in the right thing. Yeah, it's just a typo. Okay, save. Now I can check this in, and I'll say add transmission delay estimate to sector timer. Okay. Now, I think there are 2 bugs left to fix, right? So one is that if I hit a key on the secondary board, it crashes the board. You can see it stopped blinking as soon as I hit a key. I can reset it and it comes back, right? Primary board works. Secondary board crashes when I hit a key. The second thing is when I was running the log. Oh, I should make a separate batch file for this. But here's when I run the log, right? When I run the log here, we're not getting any messages from the secondary board. It should print something when it boots up, and it's not. So let me first fix the key thing, because then we'll at least see it on the primary board's log, which is working. We should see a log message when we get a key report from the secondary board. So let me fix that first. All right, so then we will close this. Oh, I keep forgetting to do this. Let's do it now. I was gonna make a new batch file called like log, which just does that command. Let's make sure it works. So just log will just show the log, right? Okay, so then check that in, git commit, add log.bat, which runs monitor to show log. Push that guy. Is this C#? No, it's Rust. Except for my batch files. So one way to tell that it's Rust is that the functions start with fn. What's another way you can tell? When you see the words let and mut or mute everywhere, that's another clue that we're programming in Rust. So mute is kind of like the inverse of const in C or C++. So that means that we can change this variable. If we have a variable like color here, and we don't see MUT in front, that means it's a constant. And let is marking wherever we declare a variable. Except for parameters, we don't have lets there, but we have a let everywhere else we have a variable. You don't think you're ready for a 12% keyword? So this is just my intermediate prototype. Once I like work out all the bugs and stuff, then I'll spend the extra time to actually have the target size keyboard, which for me is going to be like this corn keyboard. What is the percentage on a corn keyboard? Is it 30? Anyway, it's got 38 keys, I think, right? 5 times 3 times 2 is 30 plus 6, yeah, 36? 36 keys. So it's not actually that big of a leap, right? If we're going from 12 to 36, we're just multiplying the number of keys by 3. And nothing else really changes, other than I might add some underglow LEDs and make it look nicer than an ugly little square. There is a YouTube video of someone who made their own 14-key keyboard, I think. No, 16-key keyboard. So it's like this, only with 2 thumb buttons, and these were rotated 90 degrees. And he actually got up to like 100 words per minute with that, which is, I think, is crazy. So this is almost functional if I had thumb buttons for layer switching, which I don't have. Believe it or not. Someone has proven that they can use a 16-key keyboard. 12, I don't know about. But yeah, again, this isn't a 12% keyboard final product. It's an intermediate prototype. I mean, I didn't even make the plates to hold the switches in place. I don't have any standoffs or any bumpers on the bottom or anything. Literally just had the PCBs made, soldered the components on, and hooked it up. I don't even have all the LEDs populated, because it turns out I put them on backwards. So these should be facing down, but they're facing up. So if I were to light these LEDs, they would be, the light would be coming at the camera, whereas when it should be coming up through the keys. So imagine if I had made the final product and realized too late that all the LEDs were upside down, and then had to revise the board. I have to either desolder all those parts or buy more parts. So I'm happier that I made this intermediate board with just like half or a third of the keys I'm going to have eventually, because it lets me test stuff and I can make mistakes and not feel so bad. Like I didn't lose too many parts here, you know? Okay, so let's go look and see what I did wrong in the key stuff. That would be in keyboard, in poll, scan keys, right? So here's the keyboard scanning. Oh, right. So we just place it into keyboard report, right? And then that gets pulled from later. I think it's right here, right? Yeah, so... No, this is for the primary board. We know that works. Then where does it go from the secondary board? Oh, it's right here. So there's something wrong here. Maybe this unwrap is wrong. I bet you it's this unwrap. It's causing a panic because I wrote this late last night, and this will panic if our vector isn't exactly the same size as the array that is needed here, which is 6, right? So if I got that wrong, if codes gives us more... Oh, actually, that's the problem, right? Codes is only going to give us the number of codes that are on. Okay, then I know what the problem is. And I think I know how to solve it too. Really, I don't want codes to give me an iterator anymore. I want it to give me a array, right, with 6 elements in it. And I might as well just have it let us borrow the key codes directly, because that is exactly the array we want. The only thing is I need to zero fill the other things in there. I don't think we're doing that now. Well, actually, I guess we are, because when you create it by default, where's the default? Default's derived, right? So this will end up getting zeros. So it actually kind of is what I want. Are you particular about the switches? Not really. So these switches are just like on the right, cherry MX browns, and the left cherry MX whites, I think. So they got the 2 pins on the bottom, and I'm just using like just regular old transparent keycaps. You can see these are the cherry browns. I haven't yet decided if I want to stay with these or go to like a chalk low profile. I think what I did, ended up going with these cherry MX switches because the corn that I have uses them. So I'm already familiar with that. And I can kind of peek at their design and make sure I design the circuit board for, you know, where the switch sockets go correctly. And also I think these are kind of more universal, right? I have more options. But I am sort of in the back of my mind thinking maybe I should go low profile or broaden my horizons and pick something else that I just don't know about yet. Oh, I put that on rotated. Oops. Pop that off. Put it back on in the right orientation. There we go. I definitely like the hot swappable ones though. Including a get and a set for the key code could help order the pipe. I don't understand why I would need to do that. If I just show you the log here, here are the keyboard report arrays. So if I'm not pressing anything, it's just all zeros. If I press one key, you'll have that one key and then a bunch of zeros. If I hold down a second key, the first 2 will be out there and all zeros. And I construct these arrays like every time we scan. So what I do is I start with an array of all zeros. And then a number, we hold on to a number of things filled here, this next, and just fills it in and increments next. So I don't know why I would need to do a get or a set. We just need an add. And then I think the bug is that I'm getting an iterator, and then with that iterator I'm doing collect, and then I'm forcing it to expect to fit into an array of exactly 6, which it will only be if I hold down all keys simultaneously. Otherwise it's going to hit this and panic. So yeah, probably we like Perkin G. We would probably, you're right. If we would probably want to get in a set if we were going to do stuff like sorting, or if I was going to reuse the key codes between scans and like remove. But I think I went with this because it was just super simple and easy. We just construct a new one of these every time we scan. So yeah, let me fix this. Really, I just want to return this, right? Make it simple. So we're just going to return self key codes. We can make a copy, right? No problem, no big deal. It's just 6 bytes. Is only 1 key per step. Each one of these in key codes is 1 scan code or 1 key. Although, if we had like a key which maps to like a combo, holding down 1 key might activate 2 scan codes. But yeah, as it is right now, each one that's held down occupies 1 position, and this limit of 6 comes from the, I think they call it as like boot compatible human interface device standard for USB. And I checked on my Corn too. It has the same limitation. If I hold down 6 keys and then try to hit a 7th one, nothing happens. So there's like a maximum of 6. It's not like infinite key, or what do they call it? Infinite key rollover. It's definitely limited to 6, and that's okay for me too. So if I change that, it's gonna break this, which makes sense. So we wouldn't even need to do this, right? We just do that. So that ought to fix my bug right away. Let's build it and then program. So then the only thing left is to fix the logging. I think the logging might be broken. Actually, logging might be okay. We'll see. It might have been just that it was crashing right away. So let me hit a key. Oh, it's working. And the logging is working too. Kind of hard to see without that. So my head is kind of in the way. If I hold down all 6 keys and release them, you see up here, it actually had a report with all 6 keys in it. Okay, the camera's in the way. There we go. You can see it. It's right next to my head. So that's when all 6 keys were held down, and then it went back to, yeah, how come it's, is it delayed? I think it's delayed. Yeah, it's like delayed 1 message for some reason. Let me reset it. I mean, now it's back to normal. That was so weird. I wonder if that's something I was doing in VS Code or something. Anyway, these keys are working now, right? A, B, C, D, E, F. 1, 2, 3, 4, 5, 6. What more key codes do we need than 1 through 6, A through F? Okay, cool. So we got the key scanning and reporting across boards working, and the logging is working. Neat. So it happened to be that I had over complicated the way we do the key code representation and reporting. So it actually simplified it greatly. I like simplification. So fix issue in sending key report across boards. We were collecting an iterator of scan codes and expecting it to always be 6 codes. However, that only happens when you hold down exactly 6 keys. Simultaneously. At any other time, this would panic. So just simplify the thing. simplify the code to just relay the scan code array as is without going through an iterator. Or collecting into a vector. Both of which were like needless, right? We didn't need to do any of that. It's only 6 scan codes. We can copy it on the stack. No biggie, right? All right, cool. We're done, chat. So I can go past my original plan. Now that everything is working with the new interboard communication, the next thing I wanted to do was just go through and refactor this. So clean it up. Look for needless heap allocations and remove them. I know there were some that I remember seeing, thinking, why are we allocating this on the heap only to get a slice? Why don't we just put it on the stack or use the slice we have? I think one of them was in Programmer, where we're forwarding the program, I think. Yeah, this stuff, right? So we start with a slice, and then we put it into a vector, only to get a slice back when we're done. Why? Ultimately, we want a slice when we push into the ring buffer. Oh, wait, hold on. This encode actually does need to make a vector because it can change the size of the message because of how the encoding works, right? Whenever we see these 2 bytes, we actually turn 1 byte into 2 bytes. Okay, so that answers that question. We can't just take this slice as is and put it into the ring buffer. We have to run it through an encoder, which might add some bytes. Okay. Well, then we have to leave that as it is, but I wonder if, like, if we're always... I was just going to say, if we're always passing a slice or a reference to encode, maybe we could simplify it and make encode just own the thing we're making. I mean, to say it's always a temporary, right? It's always a temporary, so why not just let it own it? Like, I can just remove that reference there, right? Encode to vec, does it take a reference? I mean, it doesn't say it. It's generic over something that supports encode. Right? Where does this go? This does take reference to self. I know, let's see what happens if I change encode to own the message, right? If I just delete that character, then does so this still works. But I'm gonna break the programmer. Right, and all I need to do is delete that character, right? And that's working again? Yeah, I think this might be better because if we're always passing a temporary, it might as well own it. And then that just simplifies the code and it's easier to read. One less character to need to worry about, right? Yeah, I think that's just nicer. Get rid of that. Okay, and then in the monitor, same thing, right? Get rid of these needless characters. Cool. Any problems? No problems have been detected. It's only 1 key each step? Yeah. I think I already answered that. For some reason I looked at chat and I saw that question. I'm like, did I answer that question? Don't know if I did. I'm going to program twice again to make sure that the programmer itself wasn't disrupted by my change. So program a second time just to make sure. If you're wondering why I'm staring that direction, the colors of these two LEDs are telling me what state things are in. So it makes me more comfortable that I'm seeing what I expect. All right, so what's the other thing I wanted to do? Can't think of it now. Let's just go back to refactoring. I should probably check that in, right? And just say we are encode now takes the message by value instead of by reference. Okay, we're gonna do it. All right, git commit. We'll say IBC have codec. Well, let's put this in backticks. Codec encode take message by value. This just removes an unnecessary reference. Since in practice, we always construct a temporary to pass to encode. What's that sound when the device gets disconnected to your OS? So I changed my Windows sounds for USB in connect and disconnect, so that if you are running on Windows, you won't get confused thinking it's your computer. So I think one of my mods made a command called bada. Yeah, exactly. If I get tired of that sound, I'll just change it or maybe silence it. I like to hear it because it lets me know that the board is resetting correctly. If the board didn't reset correctly, I would not hear one of those sounds, or I'd hear a different sound, and then I'd be like, oh, okay, something's wrong. Yeah, there. Hey there, Metro, how are you doing? I'm just refactoring. I got everything working today. We're using this new inner board communication library I made. So the message passing between my two boards is a lot cleaner, and we can extend it at any point because I have them nicely declared here. So yeah, if you're curious and you haven't seen this yet, the messages that my two boards exchange between each other, there's a greeting message that the left one sends to the right one, just to let it know that it's there, that hey, you're not alone, and you have a connection back to the rest of the world. Key is sent from the right to the left whenever I press a key. And we need that because the right hand side is not connected directly to my computer. So it has to send a message, this key message, whenever the key state changes, like I hold down a key or release it, so that the left one can get it and then say, okay, I'll include those scan codes in my key reports over USB. Log is when we're in this logging state. So this diagnostic log here, you see at the bottom, if the left-hand side board I do some activity, it's just sending text over the serial port. But on the right-hand side, again, it doesn't have direct connection to the host, so it has to send a log message in this case from right to left, and then he says, okay, I'll include that in my diagnostic log. So when I hit a key on the right, you actually see two timestamps. This is the left-hand side board's timestamp, and then peer, and then this is the right-hand side board's timestamp, and then the rest of its log message. Oh, that's another thing I wanted to fix. I wanted to clean this message up a little bit. I'm not exactly sure how I want to do that, though. I have to think about that, because it's sort of clumsy that we're printing info keyboard when really I don't care what the left-hand board had to say. It's the right-hand side board's log message, right? So it would be really nice if we had like L and R in front of the timestamp, so we know like which board it came from. That's, I think, how I want it to look like, but I have to think about how that'll work. Playing with the rocket library. What's the rocket library? What happens if you connect the right-hand side of the computer? Then the right-hand side becomes the left-hand side. You want to see that? It's pretty cool. So right now, left-hand side, is 1, 2, 3, 4, 5, 6, right? And the right-hand side is A, B, C, D. So check out what happens if I disconnect the left and connect it to the right. Now, the left-hand side is A, B, C, D, and the right-hand side is 1, 2, 3, 4. So basically the way I have it coded, if I show you keyboard.rs and we go to scan keys, it's this one. Each side of the keyboard should define its own separate codes in a cleaner way. So right now I just have it, if you've received a greeting, in other words, you're not the one connected directly to the host, you're the other one, then you have scan code starting from 4, which is, I think, A, B, C, D. Otherwise, you use scan code starting with 30, which is 1, 2, 3, 4, 5, 6. So which side is which is purely dependent on which side I connect to the host. So by convention, I would connect the left-hand side, and then it's correct. Now, if I wanted to like sort of hard code which side's left and right, these boards don't intrinsically know which side they are because I never encoded that in the PCB. What I've seen other people do, though, is they will have like a reversible PCB, and they'll have either a solder bridge or a 0 ohm resistor that they will either populate or not, or if it's a solder bridge, they either put a blob of solder or not, and then that tells the board when it boots up that, hey, I'm a left-hand sided board, or I'm a right-hand sided board. Another way to do it could be that I might have a configuration program on the host where I can say where I intend to like always plug in the right-hand side, so it could send a message to the board, and they could update the firmware somewhere saying, well, if you're connected to the USB, then you're the right-hand side. Otherwise, you're the left. Or, flip it around and make it back the other way. But yeah, right now, it's just I have it hard-coded that whichever one I plug the USB into is the left-hand side. Rocket.rs is a Rust web framework. Oh, that's right. I forgot that Rocket was a web framework, mostly because I wrote my own web framework in Rust. I like to write stuff by myself from scratch. That's cool, though. Okay, getting back to what I was doing, did I check this in? I did. Why do I have this there? I don't know. What's the last thing I did? Right, I just did a bit of refactoring. I guess we're still looking for refactoring opportunities. Should I go from the top? I didn't touch this, so I'm not going to look at it again. This one I need to review. Okay. Right, so from the perspective of the board that's giving us commands, we can either be like operating normally, or we might be in the special mode where we're receiving a new program. And those are the only states we have right now. And we advance through the state machine whenever we receive a message. If we're in the normal state, we can receive a new program. If we're receiving a program, we expect to get sectors one by one. That looks good to me. So if we receive anything but the beginning of a program sequence, we drop it. And if we're receiving a program and we get anything but a sector, we go back to the normal state. So we basically abort programming. That looks good to me. Actually, I like how this reads now. This looks a lot cleaner than it did a week ago. So if we receive the program size, we announce, hey, we're going to be reprogramming. Here's the size. And then we go into that receive programming state. And then we receive a sector. We see how long it is. We zero pad it. We log it. We program it to flash in the staging area. We advance to the next sector. If we receive all of the program, we construct a programmer, which is another state machine, and we say, hey, programmer, program this many bytes into flash. And then as far as the controller is concerned, we go back to the normal state. If we're not done, we stay in that state. Sounds good to me. this state machine produces the next state, and then it possibly, like this option, it possibly gives us a programmer state machine. So looking at where that's called from here, if we get a programmer state machine, then we switch to showing either purple or red. Why would we ever show red? I think this is dead code because we end up changing our LED immediately back to white, don't we? If we're receiving. Yeah, because doesn't this... No, that's not it. Yeah, right here. If we're receiving a program, we go immediately to white. So why did I have this set it to red? I don't remember. Anyway, when we get a programmer, that goes back out from process control input. And that goes all the way back up from pole USB. Oh, that's interesting. We have a tail called a pole peer serial where that returns the programmer also, right? Because there's two ways we can get a programmer. We can get it from the host or we can get it from the other board. Yeah, so in either way, it percolates back up from pole, right? And pole stores it, and then if we I guess we always have one, right? Yeah, I think the way I did this was programmer itself has two states. Actually, it has four states. And inactive is the initial state, right? So we're either not programming, we're sending our program from left to right, or we're waiting for the right board to finish the sector we just sent, or commit means we're ready to update to the new firmware ourselves, right? So here's that state machine. So if we're ready and we're the left-hand board, we need to forward our program to the right-hand side first. So we do that same program size, go into the forwarding program state. If we're not the primary board, we've received the whole program, we're ready to commit, so we just do it. Right. If we're forwarding the program, we figure out what's the next sector size, we find out where it is in the staging area, we encode it into a message and put it into our ring buffer, we log a message saying we did it, we start a timer, and we go into the pause state. The pause state, we're waiting. If we're done waiting, and we're at the end of the program, turn the pixel red and finish. If we're not at the end of the program, we go to the next sector. So we just update our offset. That offset gets updated here in advance, right? So we go back to forwarding program and we read from the staging area and write it back out. Okay. I can totally read this, so it passes my test. Whether other people can read this or not, I don't know. It's magenta, not purple. Is it though? Okay, simple, effective. We'll say it's magenta. I wish my camera was better. I mean, you can barely see the color of this, right? You just have to take my word for it that right now it's green. Green, we use green in the normal state. Okay, what else should I inspect? Probably in keyboard, I should take a look. Weren't there a few things I wanted to rename? Set up our blink timer. Set up our sector program timer, our greeting timer. This is our main loop for the keyboard. We set up the blink rate depending on if we're the primary or not. Oh, I wanted to fix this. This is like a really weird name, is primary controller. Really what it should say is connected to host directly. Like is USB configured maybe? Because we're always going to use USB to connect to the host, right? So why don't I just call it is USB configured? That's literally what it checks right there. It just needs to make sense in all the places we use it. So does it make sense here? We're polling the peer serial port. If USB is configured, then the data we receive is going to be decoded. And if it's a key report, we store that in peer keys. If it's a log message, we log it. Oh, I should work on that next. I should clean up the log so it says like L and R for left and right. Okay, so this makes sense. If USB is configured, then the peer is our secondary board. If it's not configured, that means we are the secondary board. And so what we receive is our control input. Makes sense to me. Next place. If USB is configured, then we use purple while we're programming. Otherwise, we use red. I don't think this is correct. Because it should really only shine red when we're done. Let me search for this. Make sure that that's correct. It's right here. Okay, so I was wrong. So if we are sending a program from the left to the right, and we are done, we change red at this point and then update our firmware. That means the secondary board must be hitting here when it turns red. So how? I don't get it. Oh, maybe I do. Maybe I do. Maybe I do. So it would be going into here, right? And it would be done receiving a program. And would get, yeah, exactly, right here. Got it. So if we're the secondary board, we only use the commit state because we're not forwarding or pausing or being inactive, right? Okay, I got it. So let me just annotate it then. If USB is configured and we have a programmer, then we are forwarding, which is purple. Otherwise, we are upgrading, which is red. How many states does the controller have? I think it only has 2 right now. Yeah, we're either in the normal state or we're receiving a new firmware update. I should change this, right? This should be something like a firmware update. Right? And let's rename this one too. So I don't know a better word other than normal to say like what state it's in now where we can hit the keys, right? It's in the normal state of a keyboard. And when we're in the firmware update state, we really can't operate as a keyboard anymore because we're reflashing. I don't know if I'll ever have more than these 2 states. I mean, is there anything else that the host computer would have the keyboard do other than operate as a keyboard or update the firmware? Idle? Oh, like if like the host goes to sleep and the USB goes idle? I suppose. How would I test that though? Purposefully. See, if I put my computer to sleep, I can't stream. So I'd have to do this with a second PC, right? So Perkins, you might be right. I might want to support an idle state when the host has gone idle. Otherwise, it's going to keep operating as a keyboard even when the host has gone to sleep. And I suppose if we're idle, we would just shut off our LEDs, right? Go into a low power state if we can. Yeah. Anyway, that's all. So possibly idle. So that I don't lose that, let me make a note. Areas that need work. System stuff. So this one was an idle state for when the host is asleep. I should update these two, right? I haven't worked on key stuff in a while. This one's done. We just finished that today. The addressing is easy because I decided to make just a daisy chain. So I'm going to say that this is done also. Yeah, I haven't done any of this stuff yet. Well, this I sort of have. I want to do one more final pass. I want to look for all the places where you use the unsafe keyword and see if we can remove any of them. But I haven't done any of this yet. We're not using the second CPU core. I haven't verified our RAM usage, and I haven't put the heap in properly. We have it hard-coded right now. Is there a USB signal when the computer goes to standby? I think so, but I don't know for sure. I'd have to look that up. Where would I look for that? I guess I would look at the crate I'm using for USB. So I think it's USB device. Let's see what USB device has to say. Actually, it might be in the board support package also. Libs. Let's search for like standby or sleep. What? It's not. Maybe it's on the USB bus trait? Let's see. There's an enable. That's not it. Is stalled? Maybe if it has something to do with the stall condition, maybe that's what we would do. We would say is stalled. Suspend. Here we go. Causes USB to enter USB suspend, lowering power consumption and preparing to detect USB wake-up event. This will be called after poll returns poll results suspend. Device will continue to be polled and it shall return a value other than suspend from poll when it no longer detects the suspend condition. So this is probably it, Perkin-J. We do get a signal, however it's done, and in the crate that I'm using, it would come back as suspend. On this trait for the USB bus. I don't get that call directly, so I think I would have to look and see on the USB bus. I never saved this? What happened? Can't undo. Oh, it's a rename. I need to save all. Just sorry, I was distracted. We need to see, like, the USB bus does it have a method I can call. Oh, I have an error? Oh, what happened here? Okay, I think I accidentally did an undo and it renamed that back. Okay, back to keyboard new, right? So somewhere here is, okay, here's the USB bus. It is of type what? USB bus allocator. Okay, and then we make this USB dev. Okay, that's USB device. That's this class, that type here, USB device. No, it's not. Oh, no, it's here. So this one. Okay, there we go. There's a state, USB device state. And we would just see that it's in suspend state, I guess. Okay, so if I wanted to do something, then just like right now, I'm looking at configured. If it was suspended by the host, or it's been unplugged from the USB bus and we're self-powered, we would be in suspend state, I guess. That's my guess. Okay, you probably should check in that name change, right? Receiving program renamed to firmware update. And this one also was renamed. Okay, so there were 2 renames that I did. So we're refactoring at this point, right? Refactoring. Rename. Rename what? Is primary controller to is USB configured. Rename receiving program to firmware update. I think that's all I did. Yeah. Okay. Done. Okay, blink LED, poll, process control input, reflect programming state. I still don't like this function because it's awkward to me. It only happens when, right here, it only happens here when the programmer is first created, right? So it's not really reflecting the programming state at all. In fact, we never gave it a programmer to look at the state. So I think it's just a name that I don't like. I think it should be called like reflect firmware update. No, I don't even like that. I don't even think this function should exist actually. Because it's setting the color to one or the other for 2 completely different reasons. It's setting it to magenta or purple if you prefer whenever we start forwarding, and so I should just put it right where we start forwarding the program, and then it's setting it to red right before we do the firmware update, and that's where I should do that, right? Yeah, I think I'm going to remove this function because it really doesn't make sense for it to be there. Yeah, because I already have this thing, right? And I should just have that wherever we do commit reprogram. Yeah, I mean, I have it there. Why don't I have it here? It should just be here, right? It has access to the NeoPixel because we have to do it there anyway. Yeah, so there's no reason for me to have put it in this place at all. Okay, so then let's move the purple one to the correct place then. So I'll just copy this for convenience. It'll be whenever we start forwarding the program, right? So that would be exactly here. So now I can just delete that other function. Let's do it. Deleted. And then drop the call. Done. Then make sure I didn't break anything. Should have no outward difference. I gotta program once and then observe the new program and see if it's operating correctly. Bada. Bada. Okay. Here it goes. That's white. Now it's purple and that's white, or magenta and white. And they should both go to red near about the same time when they're both updating. Yep. Okay, cool. It's exactly what I wanted. So let's check that in. I already know what my next refactoring step will be. So this is deleting this function that is of cross concern, right? So split up contents of that. Okay, it's a little bit too long. That's okay. It's a long name, right? Change LED to magenta right when we start forwarding the program, or firmware update. Right when we begin forwarding firmware update. Change LED to red right when we are completing the firmware update. Okay, if you haven't guessed it, my next refactoring step will be where we are doing that, completing the update. And I'm picking that color. This code is exactly the same as this code, so why don't I have it in one place and make it just a function call? And I'm going to call it complete firmware update. Right? That's what it should be. They're both in programmer, so we're going to do extract into function, and it's just going to be called complete firmware update. Or finish firmware update. Complete. It's actually correct either way. It's either we're doing a complete firmware update or we're completing a firmware update, right? I don't know why that underscore is there. The refactoring tool messed up. What is the type of NeoPixel? It's this. That should be reflected here. Yeah, it just kind of screwed up. So turn the LED red and commit the reprogram. I want to change the name of that too. Okay, so then I can call that same function here too. Complete firmware update. Here it's pause between sector size, actually. Yep. What's wrong? Oh, that should be like self. No? What did I do wrong here? Oh, I know what I did wrong here. This never returns. So this should just... Why does it say it returns a programmer? It returns nothing. It doesn't return. Okay, let's find all places where it's used. Yeah, so that's final because it never returns. Excellent. Okay. I guess it can stay where it is. Let's make sure I didn't break anything. Program. We're going to do it twice because it involves firmware update. Looks good to me. D, E, F, 10, 11. It works. Of course it works. Rust refactoring is so smooth, you know? So this is extract method. Called complete firmware update. All right. Oh, this 8. I wanted to use a constant for that, right? Yeah, it's LED brightness. Does it belong in keyboard? I feel like that this should go into its own module called LED. I feel like it should. Let's make an led.rs. And I'm going to move it there. And then that becomes public, right? Yeah, because then what I can do is I can kind of make a generic set LED bright, this thing. This right brightness one's color, all this jazz can just be like a much simpler function. So let's do that. Let's make a function under LED called function, a public function. Actually, should it be a pure function, or should I make it into a type that holds on to the neopixel? Then that type of the neopixel can be like encapsulated in one spot, and it would be a lot cleaner. Yeah, let's do that. I like making things cleaner. So let's make a struct called LED. And inside of here, we'll put the neopixel. And then that means we'll have an implementation for LED. And that implementation will have some kind of public function. Okay, this needs to be public also. So there'll be a function, well, new, right? With some arguments that's going to give us the self. And in main, I need to have mod LED for this to work. Hey there, 715209. How are you doing? I've completed what the stream title says I was going to do, testing and debugging the interboard communication. It's all working. It mostly worked right off the bat, and I had to fix a few bugs. And now I'm just refactoring. Well, good morning. I presume it's the morning for you if you just woke up. Okay, I was going to make a convenience function here, like set color. So there's some color. I forget the type. I'll just put RGB for now. Oh, we need to borrow, I think, immutably, but I'm not sure. Okay, there's a bunch of stuff I don't know yet. But yeah, so this encapsulates the fact that we have to do it once and that there's an LED brightness and all this junk, right? Okay, so then let's get the neopixel type. Here it is. That is the type. It's ugly. But it encapsulates like where it is on the board and everything, right? Neopixel. So I'm going to need to provide it here. In fact, this could just be copied as is and put there so that I can take this and just paste it there. Now we got to do a bunch of imports. Import that. Import that. That. that GPIO 17. How come there's no import of that? Okay, that's not helping me. So where do we get GPIO 17 from? We get it from here. HAL GPIO bank 0. There. I love the reformatting that just places it where it needs to go. It's so lovely. Okay, what's the color? Color is an RGB 8. U8. Okay, I can do this. GB8U8. Probably need to import that from smart LEDs. That makes sense. Okay, and then what's wrong? It doesn't take a generic argument? Is it just an RGB8? Okay. Whatevs. A brightness is smart LEDs also. Once probably comes from core iter. And then this right is the last one that's tricky, right? It's probably going to say like I need to import a, yeah, use smart LEDs right. And then I don't want to keep the name, so we're going to do as underscore. Cool. Almost 8 a.m. Oh my goodness. Time to get up. Cool, so let's just replace this NeoPixel right away with just LED. LED. Light emitting diode. Import create LED. Okay, and we'll put it in alphabetical order. Okay, LED is just an LED with a NeoPixel in it. Actually, we had the new function, right? Exactly. There we go. All right, and now it's just a matter of fixing up all the errors. So this just becomes self LED dot set color to color. Much nicer, don't you guys think? In fact, I'm going to copy that because it's probably this same thing I need to... Oh no, this is different. Okay, so this means... This tells me that... does it even need mutable access? This right didn't need mutable access. I think we can just borrow it in the programmer, right? So this can just be LED. And this can just borrow LED. Import it. Right, because all we really need to do is do set color with this color here. Cool. And then complete firmware update needs to just take an LED. Borrow an LED. It's much cleaner this way. I love it. And then this LED is just set color with here's a color. Much easier to read. All right, what's the problem here? It does need it to be mutable. Oh wow, mutable it is. Which means this needs to be mutable. Which means this needs to be mutable. Which means this needs to be mutable. Again. Okay, we have some... Right, so these got pushed down into LED, so we don't need them anymore. Nice. This will clean it up a bit, right? And then probably in keyboard also. See, this makes me feel good about the refactoring. That we're removing like imports that we don't need anymore because they've been consolidated into one place. All right, so build it and program it. Yeah, this is neat. I mean, not even my Korn keyboard here has this ability to program both sides simultaneously. I really love that I spent the time for that to do that feature. Program once more to make sure it's still working. So yeah, it's white, now it's magenta and white, which means it's forwarding and receiving, and they both go red when they're firmware updating, which is right now. And then they reset back to normal. All right, let's check all that in. Git commit. So what will I say? Refactoring again? Or just say encapsulate NeoPixel into LED type. Hey there, striped monkey. Nice emote there. We're doing some refactoring here. The goal for refactoring is to remove obvious inefficiencies, to make code readable and more maintainable. So this is one step that I did, right? NeoPixel has a really awful looking type. Actually, there's one more step I can do here of refactoring, right? We can just declare the type. Type NeoPixel equals this. So I'm just going to cut and paste. Now it's even more readable, right? Because now if I change, let's say I change which GPIO the NeoPixel is on. Not that I can because it's hardwired on the controller board, but if I did, there's only one place in the entire program where I would need to change it now, right? I believe that's correct. Yeah. This is the only place where we say that it's on GPIO 17. Because of how Rust perpetuates the types, we'd only need to change it in one place, and even way back where we allocated it in the first place, it would just get it automatically because of type inference. So where was that? Like in keyboard new. Where we get the NeoPixel? Right here, right? So we didn't have to say which GPIO to get it from because it's implied by the type. In fact, it says unknown here because it doesn't need to know at that point. Actually, shouldn't it know at that point? It builds. Why does it say it's unknown? Maybe it's too difficult of a task for Rust Analyzer to figure out the type right there. I mean, ultimately, it gets into this LED type, right? And if we go to LED, it's declared right there, so it knows the type has to be that. Interesting to me that it doesn't know the type at this point. It can't see that far back, I guess. What if I reset Rust Analyzer? Maybe that would fix it. Sometimes you can get Rust Analyzer into a state where it can't figure out types and stuff. It can't figure out errors. And mostly it's because it has to re-index. Let's see if it knows the type now. No, it still doesn't know. It says unknown. So the compiler can figure it out, but Rust Analyzer can't. Guess I'm okay with that. Anyway, yeah, that was one more refactoring step that I did, right? And this is define type alias for NeoPixel. Rust Analyzer honestly has been behaving pretty funnily. What my experience has been is Rust Analyzer is a bit fragile. it breaks if you put it under stress. And this is telling me back here that it just isn't compiling fully, I guess you could say. Maybe we don't know until you fully compile it what the actual type is. So it knows some of the types, but others it's like, I'd have to compile it completely to tell you. So it's unknown. Oh, I left that in there. I left that in there, I guess, to make sure it compiles. But yeah, this was going to be the per switch LEDs, which are on there, and this is how you turn them on. But I didn't bother with keeping it there because the LEDs are soldered on backwards, or the design to be soldered backwards. All right, that cleaned up the LED handling. So it's really just holding on to the NeoPixel 4 so that we can bury the type inside of this struct. I left it a struct with a single member because I anticipate I'll add the per key LEDs to this thing eventually. So we go through the same type, the same object, whether we want to turn on the controller's NeoPixel or the per key ones, or backlights or whatever. But also encapsulated LED brightness. Does that mean that this doesn't need to be public anymore? It doesn't. There we go. No need to make it public. Cool. No more need to export LED brightness. All right, looking for more refactoring opportunities. Let's continue. Have you ever needed to use PubCrate? I don't think so. Maybe. Oh, maybe I had. I think I might have had to use it once. Do I have that project open? No. Let me look. I used it, I think, and I don't remember if I needed to use it or if it was a convenient way to work around something else. I guess it wasn't in this project. Where it might have been was in the game. Yeah. Let's see. Remember this old thing? Yeah, I put it here and I don't remember why. I don't even remember what PubCrate means. I think, oh, right. Doesn't it mean that it's public within the crate, but it doesn't leave the crate? Like you can't pull it in from outside the crate? I don't remember why I had to do that or this. I wouldn't be able to tell you why I did it. Mostly useful for libdev. I'd have to think about why you would ever need it. Because, why not just make it public if the user of your crate peeks into it and gets it, and you didn't mark. I guess what it would be is to make a strong claim that you should never need to use this, but internally to the crate, it needs to be spread around and shared. Yeah. So I haven't need to do that for the firmware, obviously. This is a top-level crate. I guess maybe IBC at some point might need to do that. But all these do need to be public. Not my unit tests, of course. Yeah, these all need to be public. Oh, we're dropping frames. Dropped about 1,000 frames there? Or I've dropped 1,000 frames and I didn't notice before when I was dropping them. Okay, it's 11 o'clock. I don't want to stream until 1:30 like I did yesterday because I'm losing sleep when I do that. I think we're getting near the end of the stream and I'm kind of just looking for some quick and easy refactoring opportunities. Oh, there was one thing. Right, the log, I wanted to clean that up. Yeah. So the main top level logger prints this stuff, right? And we have this log record, which I have no control over. I don't really control this directly. Mm-hmm. Nope. Okay, this writes to a log writer. What if I wrote... Thing is, the logger on the secondary board is also putting in timestamps and stuff, right? Oh, how do I want to do this? Really, all I want to add is an L or an R depending on where it came from, right? Yeah, okay, so I know how I want to do this. This logger gets the log buffer writer. Where does the log buffer reader go? It goes into here. That is used. Oh, there's a to-do here. I'm supposed to move this to somewhere other than where it is. Where is it? How come it's not telling me the context anymore? That's odd. Is this a Rust analyzer thing? Hold on, let me close it. Open it. Okay, so that fixed it. See how I closed it and open it again and now it tells the context for me? Weird. Okay, so within poll peer serial, we have something that's not related to peer polling the peer serial port, right? Yeah, this has nothing to do with that. I do need to move this out. But first, let's focus on the log stuff. So receive greeting means we're the secondary board. So that means we're going to grab log messages out and turn them into IBC log message. Fair, good enough. Okay, so where are the other places where we use the log reader? Here, okay, exactly. So if we're going to write it directly out the host serial port, I need to know, is it our message or is it someone else's, right? Yeah, okay, I think I know what I'm going to do. I am going to put a prefix in front of the data. It's a slice, though. I guess, How am I going to handle this? Do I know in the logger if we're the left or the right state? I don't think I do. But I could put a placeholder there. Yeah, I know. This will be sort of a hack. We'll put a little placeholder here. We'll make it a star. It'll either be an L or an R. And if we don't know, it'll stay as a star, right? So that first byte will turn into capital L if we know it's from the left-hand side. Turn it into a capital R if we know it's from the right-hand side. Okay, so then here, where we know it's the left-hand side, because it's our own buffer, I will, oh, how do I know which byte's which, though? Shoot, I don't know. This isn't going to work. Oh, what if we just, instead of using star, we just make it an L, and we're overwrite it to an R. That's what I'll do. We'll change that L to an R if we know it came from the other board. Right, okay. So if, when it's originally logged, it'll be an L for left, and it'll just remain in there if it came from here. But if it went over the it goes over here, right? Yeah. When it goes over this log, we're going to want to turn that L into an R. We can do it here, or we could do it on the other side. I'd prefer to do it on the other side. So let's look for where this is referenced. Here it is. So instead of going through our own logger, let's go directly to the host serial. No, let's go directly to our own log writer, our own, what did I call it? Shoot. Log buffer. Let's store a reference to the log buffer writer. That's what I'll do. Let's store a reference to it. Log buffer writer. And we'll just write to it directly. Not sure if you know, but now you can use the path of the item for the doc links. For example, duration, standard time duration. You can? That's cool. Don't even need to specify the full path if the item is imported already. Neat. I didn't know that. That's good to know. Thank you, Great Jack. Okay. Fix compiler errors. So we need to put it in here, right? Log buffer writer. Okay. It's going to complain that it's been moved. So we'll go to where it's been moved and we'll do a clone. I'm pretty sure I made that clone, the writer, clonable. Did I not? Hold on, I thought it was clonable. It should be clonable because it's an arc. Oh, I'm being rated. Strager, you rating me again? How nice of you. Hello, everybody. I'm just refactoring the firmware for my prototype keyboard here. I did some work earlier today to test and fix all of the interboard communication. So this 4-conductor cable that goes between the boards, yeah, it's an audio jack, but it works for power and ground and transmit and receive just as well. So it's a split keyboard, obviously. It does work. So if I put my cursor there and I hit the keys here, the left-hand side is just, I made it do the scan codes for 1 through 6, and the right-hand side is A, B, C, and D. It works. We need interboard communication because only one side of the keyboard is connected to the computer. The other side has to go through the first side to get to the computer. So when I hit a key on the right-hand side here, it's actually sending a message using my protocol from right to left, and then it puts the scan code it got from the right into its own list of scan codes that it reports to the computer. So I worked on cleaning that up today. Hasn't everyone moved to Carbon now? Ha ha ha. No. From Rob to Strager to me, huh? That's cool. Yeah, so I did not come up with this idea to use a, what they call a TRRS. TRRS. Tip ring shield or sheath or something. The Corn keyboard, which I have here, also does that same thing. That's also a TRS cable. So I kind of just reuse that design. But do you see this other silver connector here next to it? I read online that some people prefer to use USB-C, and you don't need to use all the conductors. You just, again, you only use 4 of them. But it's reversible and it's safer electrically. So I also wired that up and proved that that works. I don't have a nice flexible cable for it yet, but that's coming in on Friday. So I might switch over to that. I dropped some frames there. I might switch over to USB-C later. But right now, TRS because it was simple and I had the cable for it. 40 plus years of programming. I first started programming in what, 1980? Something like that. So how long is that? 40, yeah, it's been 42 years. Now, it's not continuous years. I did have to go to school, and I didn't do as much programming while I was in school, but yeah. Well, yeah, there's a reason why I have gray in my beard. I'm a little bit older than your average Twitch streamer. They had the Apple II back then. That was the first computer I programmed on. And it was BASIC, Apple BASIC. As in, like, go to 10 to do a loop. What was it to do a function call? Was like jump to subroutine JSR or something? Or no, call. You could do a call. Was it call minus 151 went to the monitor? Something like that. It's been so long. Well, computers have changed a lot since then. Went from the Apple II to an IBM to a 386 IBM. I don't know if we still called it IBM back then. And I've gone from what was the operating system called in the Apple II? Was it just called DOS? To IBM DOS, to, PC DOS, to Windows 3, to what was it? I can't even remember all the operating systems I've done. GW Basic? I just remember it was Apple Basic, and then I went from basically that to Pascal to C++, and then I picked up C at some point. I've done a lot of stuff. What am I doing now? I'm working on this project I can give you a link to, where we are making I'm making my own keyboard. So I'm doing both the firmware that runs on the microcontroller here, and I designed this circuit board. So, for example, I can pull up KiCad and show you the schematic. Let's go, since I'm kind of demonstrating what I'm doing, here's the schematic for my keyboard. Here is the microcontroller. Here are the switches. So if you're familiar with a ghost-free, what is it? No ghosting key switch matrix. We use a diode for every switch, and we use columns and rows, and the idea is that you let most of the columns float high, but then you drive them low one at a time, and then you sample the rows. So you drive column 0 low, and then you sample each row, and whichever rows go low tells you which of the switches in that column are being held down. And then you let column 0 float high again, and you let column 1 go low, and you read the rows again, and that tells you if switches 2, 4, and 6 are held down. And then I intended to have per key LEDs, but I accidentally put them in upside down on the layout, so they're actually underglow LEDs. We'll have to fix that later. But it's just the NeoPixel, and they're daisy chained. And I have, like I said before, I have 2 ways to connect the boards. And you can see here that it's just a UART. So there's power, ground, and UART to the right-hand side and from the right-hand side. From the left, this is the left-hand side's perspective of it, right? And here's the right-hand side's perspective of it. And that's basically it. There's a UART, a NeoPixel, daisy chain, rows and columns. Power and ground. I'm not even using the 3.3 volt out. I don't know why I kept it there, but I did. So that's that, and now I can show you the layout of it, just to prove that I actually did this thing. This ugly little square is a prototype. I actually designed it with both halves with this breakout connector, breakout things in between, so that you physically snap the board in half when you get it back from the board house. What layers are we looking at right now? Let's look at the front side. So looking at it from the front, there's the controller. I mean, you can kind of see it in the camera, right? The controller, the audio jack, the USB, and each of the 6 switches. And if we do it from the back layers, this is where the NeoPixels are supposed to be, although I had it backwards, so they're actually pointing down instead of pointing through the board up. But I had quite a lot of fun. I forget which stream it was, but I did all the routing, and it's kind of cool when you look at all layers at the same time. The reds are the front-facing copper, and the blues are the back-facing copper, and then we have a silk screen layer, and at the time we had Endorn and Sarian who were giving me a lot of feedback, so their names are printed on the silk screen of my board. If I bring this closer to the camera, you can see that. I can't get it to focus right, but yeah, it says thank you for your support, Endurance-Arian, and then over on the right-hand side, I put my name there. That's the advantage of doing your own circuit board design. You could put whatever the heck you want on the silk screen. You could put your name, you could put your dog's name, you could put a picture of your dog, whatever the heck you want. And this is the first board I've ever designed. You can do this too. Just watch about 5 hours of YouTube videos on KiCad, K-I-C-A-D. It's free. There are nice companies out there that will, like for this, was like $15. I got 5 sets. I could make 5 of these silly 12-key keyboards for $15. Plus my time and effort in designing and generating the files and sending them to the board house. All right, what else did I miss from chat? Thank you, Ellen Media. I think it looks amazing too. So this is a silly keyboard. It is not my final end goal. My final end goal is something like this Korn keyboard, which is 36 keys, I think, if I'm counting right. So 15 keys on each side plus 3 thumb keys. Obviously, it's a split keyboard. I'm kind of inspired by the Korn keyboard. I didn't go to the full product right away because first circuit board, I knew I would make mistakes. The mistakes I made, these LEDs are facing the wrong direction. So they're shining down instead of up. Also, I didn't make any room for standoffs or bumpers. And I haven't designed the plates that hold the switches in place, so the switches are kind of loose, right? And I haven't designed any of the 3D models for the like the case that it'll fit into. I'm glad you're doing well, C Films. I'm doing well too. Thank you for asking. How much did it cost? This circuit board cost $15. The components that I soldered onto it cost more than the PCB itself. Probably all said and done, I'd say this cost $50. Like the controller, each one of these is what, $8, and then the switches come up to be, I don't know, $10, and then it adds up. So if you have the time and you have the knowledge, you can build your own keyboard for cheaper than it would cost to have a custom one built. But it's still going to be a bit more expensive than a cheap keyboard because it's not mass produced. You're basically making a prototype, right? Yeah, we're up to 12 keyboards. Yeah, if you looked at my early streams, I had a solderless breadboard where I had 2 of these guys and then the controller. Now we actually have legitimate connectors between boards and sockets and PCB to plug it into. Yeah, it's kind of a nice one-off. I don't know if I'll make more than one of these. I don't know. Maybe I'll auction them off. Nah, that's okay. I was thinking like auction them off to my top viewers or something, but who's going to use them, right? I'll probably just give them out to some of my friends. All right, anyway, today was all about getting the protocol between these two. Let me go over that to show you if you're interested. Or just a review. So I made a common crate called IBC that goes between the firmware loaded here and then the control program on my computer. And I define all the different messages that I want to have. Greeting is when the left-hand side is saying hello to the right-hand side, which is important because the right-hand side doesn't know if it's waiting to be plugged in to the computer or if it is the secondary board. So greeting says, hey, you're the secondary board. Send your key reports to me. And that's what key is. Whenever I press a key on the right-hand side, it's actually generating one of these key messages and sending it to the left-hand side where we take the 6 scan codes from the right, combine it with any scan codes from the left, and we send it to the host. Log is where we're sending any diagnostic log message from the right to left to be combined with those and sent to the host. And program, size, and sector is the firmware update process, which is kind of cool. I like that. When I send the firmware to this board, it automatically forwards it to the right board, and they both update together. Let me do that just to demonstrate. So just run this program script, and So here it says programming sector, and then it's forwarding the program, and then the peer is saying programming sector. And then when it's done, they both go red, and then they both reboot. Hold on a second. One of my kids wants to say goodnight. This will only take a moment. Be right back. It didn't take long. I just wanted to hug it and kiss and a good night. All right. So not even my Corn keyboard has this, but yeah, my firmware will self-update and it will replicate from left to right. Hey there, Endurn. Did you just type the binary for Mr. Numbers 715-209? Yeah, so that's the log and the programming. And all that's communicated over these messages. So last couple of streams, I turned like the ad hoc text-based messaging between these two boards into something more professional where we declare it as an enumerated type. And I have some unit tests, and we're using bin code to encode that. That's what this derive, encode, and decode are for. So that like greeting becomes a 0 byte. A key becomes a 1 followed by a 6 followed by the scan codes, right? And you kind of makes sense, right? Hello becomes a 2 followed by the length 5 followed by HELLO. Program size is a 3. So the first byte is always which enum variant. So it's 0, 1, 2, 3, 4. So program sector is a 4, number of bytes and then the bytes. So pretty simple stuff, right? And then because we don't know if a byte is actually the first byte in the message or some byte in the middle, I have made a really crude framing protocol on top of that. So the idea is that we don't know where a message begins, so let's just pick a byte to mark the beginning of every message, and we'll make it FF, right? Well, that means we can't use FF in the middle of a message because it'll be misinterpreted as the beginning or the end of a message. So we have to encode an actual FF to be something else. So I picked FE02 is an FF, which means FE itself is an escape character. So how do you transmit FE alone? Well, you do FE01. So that I put into this codec. So when we encode, FE turns into FE01, FF turns into FE02, and we push an FF at the beginning and the end of every message. And then decode is kind of like a state machine. First, we're searching for an FF byte, and when we see it, we're going into this next bytes. So FE is our escape character. FF means we're at the end of a message, so we can decode it and return it. And when we're in the escape, a 1 is an FE, and a 2 is an FF. Makes sense, right? I hope. We have our own unit tests here. So hello FF turns into beginning of message, and then the encoding of that program sector hello, which is this stuff, and then this FE02 is an embedded FF. That FE becomes FE01, end of message. So whenever I can, especially in shared crates that are meant to be used in multiple places, I like to do it with test-driven development and have lots of unit tests. I encourage everyone to do this. So I did it for my ABC library. Both the codec and the messages have lots and lots of tests. And then we use it over here. Not exactly there. I guess the easiest way would be to just go here and search for like key. Find all references, and we'll find that here's where we receive a key message from right to left. We just store those peer keys, combine them later, and here's where we send them. So whenever we've just done the rows and columns thing, and we know we are the we've received a greeting, so we know we're the secondary board. We're going to put into the ring buffer that's going to be sending to the other guy this key codes message. So again, using that codec with the key message, and the IBC library takes care of all of the serialization and the framing and all that, and we just need to send it over the UART. Uh-oh, Endurn, you're becoming a computer, and we now will need to write an interface to talk to you. Is that right? Okay, so before I got rated, what I was in the middle of doing was this log message. I was making the output of that look a little cleaner. Because like, if we look back at this, log messages from the primary board look nice. We have a timestamp, we have a level, we have which module the log message came from, and then we have the content, right? Well, if it comes from the right-hand side board, it's a little complex because we have that guy's timestamp, level, etc. But then it gets forwarded to the left board, which puts it in its own log so that it gets another module and another level and another timestamp. So I'd like to clean it up. My vision is to make it look just like this, but have an extra character in front, L or R, so we know which side is logging. And then sort of transparent. We don't care that it got forwarded and all that stuff. We'll just see which messages come from the left and which ones come from the right. And I was in the middle of doing that, right? So, yeah, it's here that I need to change. Instead of taking a log message and re-logging it, I wanted to make it go directly to the ring buffer, but then change the L to an R while we're doing it. And we can do that because we own the message here, right? So I can literally go log message dot as mute, right? Can we go to bytes and change them? No. Can I index a string? How do you change a byte in a string? Or a character in a string? Can I just index it? I'd like to just say this. I don't think we can though. Is it as bytes mute? I mean, that's the easiest way. As a mutable slice of bytes, and we just go to the first one and we just set it to R, right? Can I just do that? We have to mark it as mutable to do that. Remember, everything in Rust is constant by default. What's the error now? It's unsafe. Oh, as bytes mute is unsafe? It is. Okay, I want a safe version of that. Okay, I don't know, so I'm going to use Google. Or in my case, DuckDuckGo. So Rust, change character and string. Sometimes the simplest things, like, are harder to do in Rust because they're not very safe. The easiest way to do is replace range. Oh, that's easy. It'll panic if the range doesn't start. Okay, that's fine. So we'll do dot replace range from 0 to 1, right? Replace with a slice, so that's just a slice R. And then we're going to need to unwrap that, right? Because it actually does it. What does it return? It does not return anything. Is it just going to panic? Okay, so it'll panic if our log message is empty, but it should never be empty. Okay, and then instead of logging it, I want it to go directly to the same ring buffer we use for our own log. So that's log buffer writer, and that's push. I want to do the same way we do our own log. So where was that? Hold on. It'll be if I follow this hierarchy. Inside of logger, right down here. Okay, it's as bytes from a string. Yeah, so it's just as bytes. Find myself lost, go back until we, okay, here we go. It's going to be log message.asBytes, right? And there we go. So the only problem I have is I need to make sure I can clone my ring buffer writer. I think I forgot to implement that clone. It's easy to do because I use this asynchronous reference count. I think I just need to implement clone, don't I? Let's do that. So derive is lowercase here, right? Clone. We can derive clone, right? So that fixes it. It's like magic. Let's build it. See if it works. Is this USB configured branch? How controller determines which side? Yes. Well, sort of. Theoretically, you could have both USBs plugged in, and then they'll both think that they are the main board. And they'll both send a message to each other, and then they'll get really confused because they'll be like, hey, wait a minute, I'm plugged into USB, but I'm also getting a greeting that says I'm the secondary board. So to answer the question, like literally, is USB configured returns true if we have this plugged in. But it doesn't mean that it's left or right necessarily. I just by convention am plugging in the left-hand side to the USB. For purposes of which one is like in charge when we're going to do a firmware update, it's the one that is the USB plugged in, and it sends a greeting to the other board, and when he receives a greeting, he says, okay, I will be the one receiving any firmware updates over the peer-to-peer link, not the USB. And then by convention, if it receives that greeting and it knows it's the secondary board, so to speak, it also, by convention, says, okay, I must be the right-hand side because the left-hand side is the one plugged into the USB. So there's a lot of convention in there, and there's a combination of plugged in with USB and then receiving something on the peer port. So there are these weird corner cases, like I mentioned just a moment ago. If you plug in both USBs, it's going to get really confused. I'm not handling that case right now. So wouldn't it be secondary and primary instead of left and right? Well, yeah, but I've sort of by convention saying primary is left, secondary is right. Just for my own, well, just because I'm lazy. I need to go, when I refactor this firmware, I need to be, to lock that down. Probably what I'll do is I'll have, as part of the configuration process for the keyboard, you will burn into the firmware which side is left and right. And that will be, I have a place for that. Because what's the difference between left and right? Literally, it's what scan codes you want generated, right? So where I do the scan code generation here, I just have it with a fix-me. Each side should determine its own scan codes in a cleaner way. Right now, it's if you've received the greeting, then use one range of scan codes, otherwise use a different one. And these are hard-coded because right now I have left-hand side doing 1, 2, 3, 4, 5, 6. The right-hand side is A, B, C, D, E, F. 4 happens to be the scan code of A. 30 is a scan code for 1, and that just, add 2, 4, and 1, 3, 5 to generate the codes from the rows. So yeah, in the future, I will probably have it burned into the firmware somewhere. The board will be told you are the left-hand side board, and this one will be told you are the right-hand side board. Or alternatively, what I've seen done is sometimes, especially on boards that are reversible, like you can flip it around, that there'll be either a 0 ohm resistor or a solder pad, two solder pads close together. So you either populate the 0 ohm resistor or you don't, and you either bridge the solder, the two pads that are close together, you either bridge them with solder or you don't. And then when the board boots up, it checks that as a GPIO input. And if it's high, it's left. If it's low, it's right. Something like that. I think I prefer having it something in the flash that I can reprogram so that I can, when I set up my keys, I can say, I want this board to be left, I want this board to be right. And then it doesn't matter which side you plug the USB into. They just know by that whether they're left and right, and that only really controls the scan codes. Whatever side you plug the USB in, it has to be the one that's the primary board because it talks directly to the computer. The other one has to talk through the secondary link to get to it. Is it open source? I wish I could make it open source, but right now I'm restricted by the company I work with. I'm not allowed to do open source. The PCB schemes, I just show them on stream. They're pretty simple, so when I work on them, you can see what they look like, and pick up ideas from that. But yeah, I'm sorry I can't share them right now. Maybe in the future. I mostly stream because I like working on this, and I know other people kind of like to watch it too. And I wish I could share everything, but I can't. But I share what I can. Screenshot all of them. Yes, you could do that. But technically, you would be breaking my copyright. My license has to be that I retain all rights. I cannot license it open source, so you would be stealing from me. Even if I wanted you to steal from me, that's what you'd be doing. Yes, some people like Endor and just listen to me talk. And that's fine too. All right, this built, right? So let's program it, and I want to see if my log is clean now. So we'll see one more dirty log, and then the next time it reboots, it should be clean if I did this right. So now they're updating. There we go. See, left, and okay, that's almost right. I think I forgot a new line in there somewhere, though. Yeah, there's a new line missing somewhere. That's a bummer. See, there's like a right-hand side keyboard message, and then there's a left-hand one glued to it for some reason. Well, that's odd. It's like trailing the other one for some reason. What if I reboot this guy? The first message was clean. No, it wasn't. I just thought it was. Oh, I know. I am not including the new line in the log message. So if I did, it would be clean. Okay, let's fix that. Yeah. Where was that? Just go back until I hit it. This is where, right, this message doesn't have a new line in it, but we need to put one in here. What if I just transmit it with a new line in it? That's the easiest, so then that would be final references to that. Yeah, so just not trim, right? There we go. So we don't trim it, and so it naturally has one in there. Build again. And program. That one depends a lot on the country and the license. I suppose so, but me being in the US, I believe that unless I set a license down, everything is like by default copyright to me with no license given. I could be wrong. Not allowed to open source the code that you wrote even in your spare time. That's correct. It's a condition of employment. If I were to start releasing open source, they could come after me and say, well, you're fired because we told you not to do it, you agreed not to do it, and you did it anyway. I'd rather make everyone happy as much as I can and wait until I have authorization to do such things. Okay, sometimes this happens where there's a delay in connecting, and I don't really understand why, but it has something to do with my computer, not my keyboard. Because when I try it with my MacBook, it's no problem. I just have to be patient and like ramble on. I think maybe while I'm waiting, I will just assume that this works and check it into Git. Okay, that is a side effect of having KeyCat open, so I will just undo that one. Okay, it connected so I can test. Left, right. Cool. So every time we do a right key press, it's actually echoed on the left because of how we forward it to the host, I think. Yeah. It's interesting how the timestamps are kind of skewed. Like, if I hit this button and hold it down, really the second message happened first. Even though the timestamp shows that left hand seems to have happened first, it's really the right hand side that happened first. And it got forwarded to the left, which reported it. In fact, there we see the last message there has the 4 scan code, and then the one preceding it has 30 and 4 because I'm holding down 30 on the left and 4 on the right. Releasing the left, it's just 4. Pressing the left again is 30 and 4. Releasing the right, it shows the right hand, yeah, it's showing it, so it's delayed. The log messages from the right hand board are delayed. Oh, that's the difference then. That's how much it's delayed by. 160 milliseconds. If these things were booted at the same time, actually there's a way to guarantee that. I'll hold them in reset, right? And then release them together. So now they booted at the exact same moment. So when I hold down that, okay, it's actually much closer in time. They're like 10 milliseconds apart. So like a 10 millisecond delay in processing the log messages from the right-hand side board. Cool. Oh, and this SPS, by the way, that's like my FPS, only it's scans per second. So that's our polling rate, our effective polling rate. We're scanning the key matrix 100,000 times per second. That's plenty fast, right? We could probably scan at 1/10 that rate and still I would never miss a key. I'd have to be typing extremely fast to miss a key press at that rate, right? Okay, I love that I have my log all clean now, so let's check that in. So git commit. So this is clean up the log. So we are do not relog messages from secondary board. I don't know why I put a asterisk in front. I'm going to say instead mark which messages come from which boards. With the first character of each log message. And write all log messages received from secondary board directly to the same ring buffer our own logger is writing to. If I start typing too fast, that happens, by the way. Did not mean for that to show up as a diff, so close that. Git push. Okay, I need to get some sleep soon. I'm down to the end. Anybody have any questions before I go? Could you use interrupts instead? Probably. That's an improvement I wanted to actually keep track of. So let me put that in here. Systems, well, it's really board stuff, right? Use interrupts instead of polling. For keys. So there's one thing I can't use interrupts for, I think. Well, no, that's not true. Technically, I can use interrupts even for USB, but it would have to be a timer interrupt because fundamentally we get no interrupt from the host to say, hey, you should check to see if you got something from me. The host actually polls us. Actually, no, I got it backwards. If we were on the host side, we would get no interrupt. We have to actively poll the device, but we are the device. So maybe there is a way to get a USB interrupt. In my main function here, run, I do this poll function, right? So a couple things we poll. We poll the USB. We scan keys and we pull the UART. I know that the UART we can make interrupt driven, so I wouldn't need to pull that. I can make the keys interrupted if I take every key and I OR them together to one GPIO, and then we just tie that to an interrupt line. So if we ground any of these switches, it would just send us an interrupt right away, right? And we would have to make that... Actually, that wouldn't work, because what if I'm holding down one key and then I press and release a second key? Because we're ORing the signals together, we wouldn't get an interrupt for that second key. I think the only way to have the keys interrupt driven is if we had each key go independently to a different GPIO, and then all of those, or two ways, either independently wired to individual GPIOs and they were all interrupt sources, or if we had an interrupt controller off board. Exactly, the nested interrupts idea. So DJS Niki, exactly, I'd have some kind of off-board interrupt controller that I fed all 6 switches into, and if any of them change state at all, I would send a pulse to the main controller. So that's an idea. Off controller. Controllers on off board. I need a word that describes what this thing is that isn't an overloaded term. How about secondary? Secondary interrupt controller to so let me turn this one into use interrupts instead of polling for USB/UART. This would be secondary interrupt controller to detect key changes and trigger interrupts. Actually, if we did that, if I had some off, like secondary interrupt controller, we could also just have the key matrix be handled by that chip, right? Because if it's getting all of these keys individually, it could just sample that state as it sees a change. Like, yeah. So that would be like a dedicated key state. Detector. And then maybe an I2C between that and the main board. Get an interrupt, and then we pull it with I2C saying, hey, okay, what's the state now? You just gave me an interrupt to tell me it's changed. You can integrate it into the main controller. I have a limited number of GPIOs, so I can do it for 6, but I can't do it for 30, for 15 plus 3, for 18. The eventual keyboard will have at least 18 keys. I don't have 18 GPIOs. So I have to combine the signals somehow in a way that I can distinguish between the signals. So that means having like a GPIO extender or something like that. I guess that would be the other idea, right? Instead of a secondary interrupt controller, it could be a GPIO extender. If I had a GPIO extender, then like maybe I would couple it with, I don't know, some logic that would pulse whenever the state of the combined state of the GPIO extender changes in some way. I can't think of it right now, but it sounds on the surface like something I could do. Anyway, I'm not going to do it tonight. Right now we're polling. We're polling at an extremely high rate. There's nothing else for this chip to do other than poll, so it's fine. Get a 5 interrupt lines? You mean like tie them to the rows or the columns or something like that? Yeah, it's a 2D array of keys. So 2 columns, 3 rows, right? And we're reading the rows, and we're driving the columns to read the rows. Okay, I'm gonna call it here. I hope you guys enjoyed watching. I wish that there was another stream that was doing something similar to me, but I don't think there is. So, well, my favorite streamers aren't streaming right now. We'll just end the stream. I will probably not be back until Friday, but I might come on for a little bit tomorrow. We'll have to see how things go. So, what am I going to do next stream? We have the inner board communication done. One of these things? I might work on this stuff. Actually, it would be kind of cool to figure out how to use the second core, but that's a lot of work. I think I'm going to clean up the way I use RAM. I got to do that sooner rather than later. That's probably what I'll do next stream. We'll be cleaning up RAM. I can show you the ugly hack I have right now in heap.rs. So I just said, hey, here's some RAM. Use that for a heap. What I really should do is I should tie that to the linker script somehow and have the linker tell me what areas of RAM are unused and just make the heap out of that. Don't think anything is used in RAM other than global variables and the heap region. So, oh, the stack, of course. We need to figure out how much stack we're using. We don't want our stack to start corrupting our heap. So I got to figure that stuff out. So that's probably what I'll do the next time. Where's my code at? It's in a private repo. I can't share it. But one cool thing I've managed to do is I have in one repo the firmware, the monitor program, the PCB stuff, and the shared libraries all together, which was kind of hard to do. I know it's a bummer. I wish I could share it, but I can't. Maybe someday. You'll have to like gather it from watching the stream or YouTube uploads. But anyway, thanks for watching. I'll be back soon. Good night, good day. Bye.